Alex J. Balan. I'm sure that many of you are familiar with him. I know that people around here mostly buy IoT devices for research purposes because these are not that secure. Alex has spent the past 5 years looking at IoT devices. His team at Bitdefender found many 0 days in smart light bulbs, webcams, and doorbell. And we're going to learn more about his research. But first, I want to show you my smartwatch. Can I do that, Alex?
Oh, that is so cool.
I'm glad you like it. So how were these past 5 years for you?
Well, I mean, it's easy to hack smart devices. So I have to admit that we went into a field where the bar was set very, very low, you know. So with
a lot of low-hanging fruits.
A lot of low-hanging fruits. I mean, virtually like 80% of all the things that we research, in 80% we found stuff with CVSS score 8+, right? So stuff that you have like remote command execution without any authentication, without like device takeover, account takeovers, without any kind of authentication or prerequisites, and all of them like trivially easy. Unfortunately, I mean, some of the most common attack vectors, I'm gonna talk about them in the slides today in today's presentation. But yeah, it's been fun. We've researched, I think, about 40 devices ish, so quite a lot. Unfortunately, the one challenge that we faced was, as Lucas said, the interaction with the vendors.
Yeah.
So the interaction with the vendors was a disaster. There were like a handful, like 3 or 5 vendors, which actually were very okay in the communication. But the vast majority didn't know what PGP was, didn't know how to communicate encrypted. They would default us to the support department or stuff like that. So
why do you think this is happening? And then we can go and watch the presentation.
It's the lack of education. I don't think that they mean bad. I don't think that they are ill-intended, so to speak. I think that they simply know how to build that particular device, and they don't know that much about how to handle security or to have an open channel with security researchers. I think that unfortunately, the vast majority of companies, not just in the IoT space, but everywhere, the vast majority of companies don't have that channel open to interact with security researchers. And if anything, I would want to raise an alarm about that. You know, all companies should have a channel open to security researchers. It's only going to make them more resilient. But telling companies that, you know, let us hack you and tell you about it, just doesn't have that ring, that, you know, it just doesn't fit well with their mindset.
Okay, wonderful intro. Are you ready to share your screen?
Let's see.
Break a leg.
Let's break some legs. So good morning, DefCamp. It's so good to see you again, I guess. I just realized that this is the usual intro, and I usually say it's so good to see you, but yeah, I miss you guys. I miss you. It's been like 2 years since we've been face-to-face. It was the 2019 edition when it was the last time we saw each other. So yeah. So let's dive into it because we have a lot of content. I don't think we have sufficient time, but I'm going to try to kind of squeeze it in. This presentation is about a summary of the most relevant things we uncovered in the past 5 years, and also some new stuff that we published this year. So about me, I joined Bitdefender in 2004. You can talk to me about vulnerability research. We have a lot of focus on IoT, but we can talk about vulnerability research in other areas as well. I'm currently running an almost rogue pen testing team within Bitdefender, which is kind of cool. Essentially, the way I got them to join was I told them that they can blow stuff up. So they're like, really? We can blow stuff up? Exactly like the Madagascar penguin. Kaboom? Yes, Rico. Kaboom. Blow stuff up. and they were like so happy, and they started blowing stuff up, and it was great. I'm running Bitdefender's bug bounty program. If you want to hack us, you can, you should try it. The attack surface is huge at Bitdefender. So yeah, you should have a look at it. Run your passive scans, recons, active scans, and talk to us. The bug bounty program, if you want, it's on Bugcrowd, and we also have a separate one running on our website if you do not want to interact with Bugcrowd. Hang on, sorry. Okay. I'm also deeply involved in the vulnerability management process. So all the vulnerabilities that we identify either in the pen testing team or in the bug bounty program have to go through a vulnerability management process. And I also just rewatched Cowboy Bebop. Awesome. If you didn't see it, strongly recommend. And also, I'm a proud DefCamp dinosaur. My first DefCamp presentation was, I don't know when, I don't remember, but I remember there were like 80 people in total that were present at the conference. About Bitdefender's vulnerability research team, we started doing vulnerability research in 2016. We found vulnerabilities with 8+ CVSS score in more than 20 brands. So as I was telling Andrada earlier, we researched about 40 devices, and we found, so 8+ on the CVSS score is bad. It's like really, really bad. It's remote command execution without any prerequisites bad, or account takeover without any prerequisites bad. So this is the fun part, but the not so fun part is that we only published 12 papers, which amount to like a very, very small fraction of our total findings. In other words, we have a ton of papers that we're sitting on and we cannot publish them because of poor or no reply from vendors. The thing is, some of the things that we found can be used for mass exploitations. And while I know some of you will say that just give them the 60 days and then publish it because that's going to force their hand, it's really not that, it's really not the case in IoT. In some cases, the vendors, even if you do publish, they won't patch it. And then that's going to put some people at risk. So we're still trying to kind of balance that out. And also very important, 4 years ago, we started to focus a lot on IoT cloud platforms. And there's a reason for that. Nowadays, most IoTs are starting to move away from port forwarding. So in the old days, you would have a security camera or a thermostat or an electrical control system or something like that. And you would port forward it so you could access it from the internet. Now that's thankfully not the case anymore. And most smart devices are just cloud relayed, have cloud relayed communication. So with that in mind, we obviously started to look at how those cloud implementations work. We published a lot, thankfully. So we managed to publish, for example, we had a very good communication with August Smartla or with Ring Doorbell. When we found, when we reported our findings to them, they replied almost instantly, and they patched their entire user base in under a month. And that's a very good metric. Unfortunately, with most others, they didn't. Now, the first chapter is reusable attack vectors and common vulnerabilities. So this is stuff that's present in the vast majority of smart devices. Wi-Fi password hijack. So this is an attack which enables you to steal a victim's Wi-Fi password if they have a smart device. And the way this goes is like this. When you initially set up a device, the process, this is a description of how the process looks from a under the hood standpoint when you initially set up a smart device. So step one, I'm sorry, I should have put step 0, you plug it in. So step 1, after you've plugged it in, it boots, and then it creates a hotspot, and the manual says you install the application, the setup application, and then it says, okay, connect to the Wi-Fi hotspot created by the smart device. Step 2. After you've connected to that smart device, it tells you, okay, I'm successfully connected to the smart device. Now I want you to select your home Wi-Fi from this list and enter your Wi-Fi password. After that, there's several other settings. You can set up notifications, whatever the device supports. Various devices support various features. And then it goes in configuring mode. And then usually it stucks and then it fails. I've seen this so many times. And then you try again and it works. Now, what happens when you're doing that in that configuration stage is that everything that you've set up in the mobile app gets packaged into a JSON file or an XML file or a text file, why not? Which gets sent to the device while your mobile application is still connected to that Wi-Fi network. The device stores that and reboots using that configuration. Part of that configuration is connect to this Wi-Fi network with this password and the other settings. Now, the one thing that happens is that access point created by the smart device is usually open. It doesn't have a password in 99% of the cases. And little known fact about Wi-Fi is that on open access points, so access points that do not have a password, there's also no encryption on that channel. And you can monitor the channel and see the traffic on that channel without being associated with that channel. So you can actually see that file going from the mobile phone to the smart device and capture it. In some implementations, that config file is encrypted and there's some sort of key exchange between the smart device and the mobile app, but in most cases it's plain text. So the attack moment is when that exchange happens and you can steal it. And if you're wondering about the vulnerability window being only in setup mode, well, hang on. The way this works involves a little bit of social engineering as well. You simply knock the device out of the network with the authentication packets. It's trivial to do. So for those of you who don't know what the authentication packets are, essentially it's a feature in the Wi-Fi implementation that enables somebody from outside of the Wi-Fi network to disconnect a device from the Wi-Fi network. So you simply keep flooding that device with the authentication packets and brick it, which will force the user to reconfigure it. And then you have your window of vulnerability to steal the Wi-Fi password. So for today's presentation, we're going to show you what we did with August Lock, because August Lock is definitely better implemented than most other devices. They were actually encrypting that package. Unfortunately, the encryption key was hard-coded and it was the same encryption key for all devices. So when we extracted our decryption key, we purchased another lock just to see if we can reuse it, and we could. So this is how the attack looked against August Lock. You start scanning the Wi-Fi spectrum. I'm going to fast forward because we don't have a lot of time. We see the Wi-Fi network, the Aphrodite Beauty Salon. Then we start monitoring that Wi-Fi network to catch the MAC address of our victim device. As you can see, there's no need to authenticate or use that Wi-Fi network. So we have the MAC address of our victim device, and now we are going to kick it off the network. And I know that this is basic stuff for most of you. What I'm trying to outline here is not necessarily the fact that you can kick off the network a device with the authentication packets, but the fact that there's that vulnerability window that you can actually get again from the user, that setup moment. So you kick it off, and then at some point we're going to see the user reconfiguring the device. So we're going to see the hotspot created by the smart lock. fast forward, fast forward, fast forward. And there we have it, August log-C5WY. Now what we're doing, we're sniffing, and we're gonna switch to Wireshark to see the packets exchanged with that access point. Hang on, and there we have the file, which is currently encrypted. So all we gotta do is just use the key to decrypt it. So we have this small Python script that is able to decrypt, and then we have the Wi-Fi password for a ringless 10. So pentru un 10 fără riduri. So that's the Wi-Fi hijack password for IoT. So again, 99% of all smart devices will create that hotspot. All you got to do is just trick the user into reconfiguring the device, capture that configuration file being sent over, and you have the device configuration, which includes the Wi-Fi password. Now we come to the cool part, because getting the Wi-Fi password requires proximity. So you cannot really do it against millions and millions of devices. So we get to the cool part, abusing cloud implementations. So an example of abusing cloud implementation is going to be the EddieMac Smart Power Outlet. So here's how cloud works in IoT. On the mobile phone, we say we want to control something about the device. We want to tell the vacuum cleaner to start cleaning, or we want to tell the power outlet to give us notifications when we're using too much power. And whatever interaction we want to have with the smart device that's inside our house, and we are gone, we are outside of the house, we are in another country maybe, and the cloud talks, the smart device in our house talks to the cloud, and our mobile device talks to the cloud. And the cloud will relay our interactions with the smart device and facilitate that communication. But the thing is, whatever is being relayed by the cloud is essentially input, right? So I'm telling the cloud A, B, C, D. The cloud will tell the smart device, okay, that guy just said A, B, C, D. And that A, B, C, D is going to be parsed by code on the smart device. And that code may be, and very often is, vulnerable to buffer overflows, command injection, various types of parsing vulnerabilities, maybe mistragic, maybe any kind of other parser vulnerability. So it's really cool, because this is not very researched. There's not a lot of research done in this direction. And a lot of the code on the smart devices is insanely vulnerable. And also, there is no ASLR on smart devices. So if you find a buffer overflow, you have a very good chance of getting predictable remote command execution. So yes, most smart devices have ASLR enabled, but it's not used because the binaries in IoT are compiled without PI, without position independent executable. So we have two papers. We have a few more actually, but for the sake of today, the EddieMac Smart Power Outlet had a command injection. So here's how that worked. Wait. So first of all, we set up a listener in Metasploit. So what we want to do is we want to tell the cloud to tell the power outlet about a command that we want to send, about an information, and we want to trigger a connect back shell from the power outlet, right? Because it's behind NAT, it's behind maybe 3-4 firewalls. In this case, it was actually in our offices in Cluj. So we wanted to trigger the power outlet to send the connect back shell to us. So we set up a listener on a VPS, I think it was somewhere in Canada. As you can see, it's MIPS Little Endian. And this is our payload. Our payload is base64 in semicolon, go to TMP and get our second stage payload and execute it. It was a command injection. I'm not going to detail it now. The paper on the command injection and how it works is on our website. But as you can see, we sent it. And by the way, I forgot to mention the only requirement for exploiting is the MAC address of the power outlet. Fun fact, a lot of researchers, after I initially did a presentation on the Erimax Smart Power Outlet, a lot of the researchers said that they're going to use this in their red team engagements. So essentially what they were going to do, and I think that what they're actually doing is they purchase the Smart Power Outlet, copy the MAC address from the box because it's visible on the box, and then they just gift it to their targets. And the moment the target sets it up, the attacker has a foothold in the target's home network. It's pretty cool. So again, the only thing that you need is the MAC address. You tell the cloud to relay your payload, and then you can see that the payload was executed. It got the second stage, and then you have a shell session open. And obviously, this is just some stuff that you can do on while you have access on that power outlet, like get the Wi-Fi password or use it to pivot and attack the rest of the network. Third thing is MQTT. So for those of you who don't know, MQTT is a messaging service, if you will, that enables quick messaging and notifications and commands between the mobile app and the device. So the device can say, I'm on, I'm off. I've just seen somebody at the door. I've just started vacuuming. I have too much beer in the fridge, whatever. And these are like short messages that are relayed to the mobile app. So you get that notification on the mobile app that says, there's too much beer in the fridge. There's not enough beer in the fridge, and so on and so forth. So the way MQTT works is that it has a tree structure. You have like /root, /device ID, /topic, where the topic is one of these events. Now, ideally, you should only be able to register to your own device ID. So when you configure your device, you establish this initial protocol. Okay, this is the device ID from the device that I own. And then the mobile app will know that it's going to register to /root, /device ID, and it's going to be able to access all the topics and notifications from that device ID. A common mistake that manufacturers make is that, so when we initially saw this implementation, we thought, okay, what if we try to access the root? What's going to happen then? And bam, when we tried that, in some cases, we started to see the notifications of all the devices made by that vendor. And pretty much the same thing with S3. S3, as most of you probably know, is that storage service from Amazon. And one of the most common flaws is that they have something like directory index of web servers activated. And when that's activated, you can access all the data from a particular vendor that uses that S3 bucket. So normally, when you see that a vendor uses S3, you can do this by monitoring what the mobile application does. It's going to start accessing files in an S3 bucket. A very simple thing that you can try is, okay, can I try and access all the files in that bucket? And unfortunately, in some cases, it's going to work. And this was actually the root cause of many hacks in the past. If you Google S3 bucket database dump or S3 bucket database leak or S3 bucket company hacked, you're going to see, unfortunately, a lot of news about companies getting hacked simply by having an exposed S3 bucket. So moving to today's presentation, I'm going to skip the description of the product. It's just a baby monitor. So MQTT, the first thing that we noticed was an unauthenticated MQTT information leak. They have their own MQTT relay server, which is publicly exposed in the internet. All you have to do is just register to it, and you're going to see the IDs of all the devices that come online. And unfortunately, there's no authentication necessary. And this is how it looks like. There's a tool called Mosquito. You just use it, register, and then bam, you're going to start seeing events from that device or from that vendor. And those events include this device ID. In most cloud implementations in IoT, by the way, that cloud ID, that device ID is the only form of authentication. If you have access to that device ID, effectively from that point onwards, you can interact with the device without having to use any other username and password. And this counts for a lot of implementation that we've seen so far. So if you manage to get that particular information, the device ID, it's usually not predictable, but for example, with an exploit like the MQTT leak, you can just get access to it. The second thing that we wanted to do is getting video feeds through RSTPs. So RSTP is that protocol that enables you to, that facilitates video streaming. RSTPs is a secure implementation of that. We noticed that in normal behavior, the camera says, I'm uploading my feed to this web location. And then the cloud is going to tell the mobile app, hey, you can see the video feed at this location. And this is how your mobile app is able to access the video feed of the baby monitor. However, what we discovered is that the MQTT implementation supported a command named command. So if you tell /device ID /CMD, you can tell it to change that upload location to a different location. So essentially you connect to the MQTT server and you tell a device, somebody else's device, start uploading your video feed to my location. And this is how it looks. We set up initially a listener, and then we tell the MQTT stream to, let me pause it, to send the RSTP stream to our rogue server. In our case, it's 10.0.0.1/media. And we see client connected and we start getting a video feed. So what we're gonna do with this, we're just gonna pipe it to VLC. And this is the RSTP hijack. So what we learn here is that MQTT was actually the initial problem. The fact that the device IDs were exposed, and the fact that it had that additional feature called CMD, which enabled anybody to change the location of the video stream. It wasn't necessary, it wasn't needed, it was just there, and probably they forgot to take it out. And there's a buffer overflow in the power outlet, in the baby monitor, which we also are going to explode through MQTT. It just gives us the possibility to give it input, and that URL change command that we sent earlier, the particular code that parses that new URL is also vulnerable to a stack-based buffer overflow. So we're setting up a listener, and we're creating the payload. The payload is going to be essentially netcut with a shell to our attacker IP address, and of course the buffer overflow payload. And we got a shell on the baby monitor. So again, as you can see, this whole thing is completely remote, completely without any form of authentication. You can do it behind 4 firewalls just by having a VPS with publicly accessible VPS that can get a connect back shell. So as end nodes, cloud-related attacks against IoTs will bypass any countermeasures. They're very difficult to block because the communication is encrypted. Usually smart devices will talk encrypted with their cloud. The communication looks legitimate because it's a communication with the cloud. The only thing that's going to kind of fall out of place is that connect back shell that you get. But you may want to run other commands. You may want to drop an APT that just periodically checks with the command and control server and snoops on the internal infrastructure and so on and so forth. So you cannot do deep packet inspection and decrypt the traffic because you usually cannot drop your own certificate authority to decrypt the traffic. So I strongly advise that any smart device that you get that's not from a reputable brand, as I was saying, August Log were great. They patched their stuff instantly. We allocated a CVE. They were okay with that. We just had a small struggle in negotiating the CVSS score. They didn't agree with us initially, but they replied instantly, and they had this very well, handle on things. It showed that they have the experience to handle this. The same thing with Ring Doorbell and anything that we found from a high-profile company. The moment the device started to become cheaper, so to speak, that was when the companies don't reply to the emails. They just send us to the support department. In one case, a company wanted to offer us a discount for their products. And they said, we are sorry that you're unhappy with our product. We can offer you a 50% discount. Guys, you don't get it. That's not why we called. We don't care about buying your product. We already have it. So military-grade encryption provides zero security against most common attacks today. I just wanted to say this. And a tricky thing about smart device vulnerability is that they're not tracked the way we're used to in software. So when you have a vulnerability in Apache or a vulnerability in an unpacker like WinRAR or our RAR labs, or a vulnerability in some parser or in some library like ImageMagick, these are tracked by CVE, so you can reference them, you can use them, they're documented. In smart device world, it's very rarely the case. We started allocating CVEs for some vulnerabilities. So there's no centralized inventory of vulnerabilities for IoT, which essentially means that only a fraction of the published vulnerabilities are known, because some guy publishes an IoT vulnerability on their blog in some place, and some guy publishes it on another blog in some other place, but they're not aggregated at MITRE, for example. So you have on the one hand, we only published a fraction of the papers that we have because the vendor didn't reply, and out of those papers, the visibility that they got was also limited because they're not centralized in a centralized vulnerability repository. And that's about it.
Thank you, Alex. I was thinking a lot about what you said and both what Lucas said earlier. And I was wondering whether you think that there could be some policy changes that could be enforced in order for these vendors to listen to you guys. Do you think this could help?
I mean, I know it's going to sound tough, but I would make it a requirement to operate. I would make having a communication channel with security researchers, I would definitely make it a mandatory requirement to be able to operate. Having that security contact and making sure that you manage 24/7, because you have a responsibility to your users and you have a responsibility to the rest of the world. Let's not forget that the Mirai botnet, because of some telnet open with root and 1234 as password, or some hard-coded password in the firmware that was reusable across hundreds of thousands of devices, caused an attack that amounted to about 650 gigabits per second. So yeah, there's this responsibility that companies need to have. You have, for example, a user base, you have a few 100,000 users, and then somebody finds that there's a SQL injection that enables them to kind of pull all the data out of that database. And then they try contacting you and there's no security contact. That's a big deal, that the privacy of the data of those users is important, and it should be. Nobody expects you to have perfect security. We don't. I mean, this is why we're running the bug bounty program, to have access to all the potential vulnerabilities that we may have. Unfortunately, there's only a handful of companies that do the same thing. So yeah, I would make it mandatory to have a security contact for being able to operate customer data.
Mm-hmm. And do you think that perhaps international bodies should have something to say about it, such as the EU, or where do you see these changes?
Well, yeah, unfortunately, even ethical hacking is outlawed in most countries, you know? So this effectively gives an edge to the bad guys because they don't care about the laws. They're just going to switch to some territory where nobody can touch them and just, have at it. So I would definitely see some legislature being changed towards facilitating grounds for ethical hackers to be able to, tamper with critical infrastructure, for example. I'm afraid to look at the critical infrastructure in Romania. because of the law. The law says that you're not allowed to do that. However, some other guy from another country is not afraid to do that. And they may find something that I could have found early on and tell them about it, and I could have fixed it. So yeah, I would want to see legislature kind of facilitating more things for ethical hackers and compelling companies to have a security contract.
So in this presentation, you basically looked at the last 5 years of your work.
Yeah.
Do you think that if we meet 5 years from now, things are going to be different, or we're going to be stuck in this paradigm?
You see, many people are against monopolies for many reasons. And the reason I'm bringing this up is that one of the problems with IoT is diversity. There's such a big diversity of devices. There's such a big diversity of cloud implementations. There's such a plethora of companies that provide cloud support for IoT, IoT platform, firmware that's OEM for IoT. And because there's such a big diversity and not those many golden standards, and even if they were golden standards, many of these companies don't follow them, then this is going to be an open case forever. I think you're on mute.
Yeah, hopefully things are going to change for the better. Allow me to be an optimist right now, because everyone is going through a lot, and we don't want to say depressing things at the end of a depressing presentation.
I mean, let me tell you something else. If they let us find those vulnerabilities and they patch them, then things are definitely going to be better. This is the way it works everywhere else. Our infrastructure in our company and our products are definitely better because of the contributions, the valuable contributions of security researchers, and we once again thank them for that. All the companies, all the legislature need to do is facilitate us with the legislature to allow us to hack, to do ethical hacking. And if that happens, then things are going to be substantially better, because we're going to force everybody to patch their stuff.
Yeah. Thank you so much